It's always important to start by reading the instructions. Download and extract the zip file. Open with Windows Explorer. Pick Extract All and browse to your class folder. You should make a new folder for this project. Review the instructions. First, we will be generating the surface rasters. Slope, aspect, hillshade will be generated from the provided digital elevation model. The Euclidean distance is based on the White County roads layer. In ArcMap, start a new blank map. Use ArcCatalog Palette to browse to your project folder. You may need to refresh to see it. Expand the Features folder and right-click to create a new File Geodatabase. It's important to use a file geodatabase at this time. Name your new geodatabase. This is where your rasters will be stored. Add the digital elevation raster to your map. Add the White County and White County roads shapefiles to your map. Adjust the White County symbol to be hollow with a thick yellow outline. Next, you should set up your processing environments. Pick Environments from the Geoprocessing pull-down menu. Set both the workspace and the scratch space to your new geodatabase file. Set the output coordinates to be the same as your digital elevation model. In the raster analysis area, set the cell size to be the same as your digital elevation model layer, and the mask to be the White County shapefile. This limits the processing to only inside the border of White County. Review the instructions. First, you will generate the slope in % rise. Confirm your Spatial Analyst extension is on. Pick Extensions from the Customize pull-down menu. Click the checkbox to turn on if necessary. Locate the Spatial Analyst tools in Arc Toolbox. Pick the Slope tool from the Surface toolbox. The input is your digital elevation model layer. be sure to set the option to %rise. It will take a few minutes for the process to run. You may want to pause the video until your raster has generated during each of these steps. You should notice the process is running in the lower right corner, and again, be patient. These take time. You can turn the new raster off to save redraw time in your map. Check your instructions. The aspect is next. It's also found in the Surface toolbox. The input is your digital elevation layer. The defaults are fine for the other options. Confirm the process has started and be patient. When your new aspect raster is added, look at the classes and notice the directions are related to numeric values. You can turn this layer off to speed things up. Review the instructions. Next is Hillshade. It's also in the Surface tools. Your input raster is the digital elevation model layer. Keep defaults and pick OK. Again, turn off the Hillshade raster for now. Review the instructions. Next is the Euclidean distance. It will be based on your road's shapefile. Euclidean distance is in the Distance toolbox. Be sure to select distance, not direction. Your input is the White County Road shapefile. Keep the other defaults and pick OK. Be patient as the process runs and your distance raster is generated. Again, you can turn it off to keep your PC running faster. Review the instructions. Next, you need to convert a vector file to raster. Add the White County land cover shapefile. Review the attribute table. Notice the cov type field correlates to the forest or not forest values using ones and zeros. Look in the conversion tools and to raster toolbox. You want to convert polygons to raster. Your input is the White County land cover. Set the field to cov type. Pick OK. Review the new raster. Notice the values are ones and zeros only. This is a Boolean raster. You can turn the new raster off and review the instructions. Next, we need to reclassify our rasters to make them Boolean rasters. We want slope of 5 to 10% to be 1s and all others to be 0s. Pick Reclassify from the Reclass toolbox. Your input is the slope raster. We are wanting 5 to 10%, which is a slice inside the data values, so you need 3 classes. Adjust the break values. The first will be 5, the second 10, leave the third alone. We are isolating these pixels. Set the new values for 0 to 5 and above 10 to be 0 and 5 to 10 to be 1. When the new reclass slope raster is created, confirm it only has 0 and 1 values. If anything else is shown, you must repeat the process. Review the instructions. We need north, east, northeast, and southeast faces to be 1. Use the Reclassify tool again. This time, your input is the aspect raster. Notice the correlation of values to directions. Just use the legend to set the new values to 1s for north, northeast, east, and southeast. All others will be 0. Watch out for the 360 north. Confirm the reclass aspect layer only has 1s and 0s. If anything else is present, you must repeat the step. Review the instructions. The next step is to reclassify our distance raster. You want the values between 800 and 1600 to be 1. Use the Reclassify tool and your input is the Euclidean distance raster. Again, we're looking for a slice of data out of the middle, so we will need 3 classes. Adjust the first break value to 800 and the second to 1600. Set the new values of 0 to 800 to 0, 800 to 1600 to 1, and 800 and above to 0. Confirm the output to be 1 and 0 only. I'll do a little housekeeping just to make things a little easier to see. Now we need to determine where all the 1s line up, making suitable ginseng habitat. Use the raster calculator in the Map Algebra toolbox. Double-click the Reclass Slope layer and then pick the asterisk. Double-click Reclass Aspect and pick the asterisk. Repeat those steps until you have all of the reclassified layers and the WC land cover raster. Confirm you have the asterisk between each layer. This will multiply their cell values. The results should only have 1 or 0, which is where you should search. 1s is where you should search for ginseng. Confirm the output only has 1s and 0s. If anything else is present, you must repeat the step. There's no need to show the 0 area. Remove that symbol in the layer properties. Make the search area dark green and adjust the label. The raster processing is complete. All that's left now is to make a professional quality map.